Well, hello and welcome to another DevNation Live Tech Talk. I'm excited to be with all you guys today because we're going to have a lot of fun. We're going to be talking about Camel K. We're talking Camel optimized for Kubernetes, and we have our two experts here with Nicola and Luca who are going to walk us through that. But one thing I want to mention, you guys showed up with great numbers this week to see our Kubernetes master course. So I know hopefully you guys have been through that master course already. If not, I encourage you to take advantage of that master course and learn more about Kubernetes if you've not seen it before. We had several hundred people show up on Monday and several hundred people show up on Wednesday for that session. And that was a lot of fun. And I make this point only because next week we're doing Kafka. So if you're interested in Kafka, you want to check out the master course link, and I'll add the link to the chat so you guys can come check out Kafka and some of the other content we have right now. But today, in our Thursday Tech Talk session, we got the two experts who are going to walk us through this technology called Camel K. And then we're also, just a little bit later, about 1 hour from now, we're going to bring you Rob Strumsky, who's going to show us the kubelet. All right, so Rob's going to talk about the kubelet, but today, right at this very moment, we're going to talk about Camel K. So it's going to be a lot of fun. I appreciate you guys are all with us, and you're having fun with us as well. So I'll go ahead and throw up my COVID-19 lockdown. We're all in lockdown mode. I'm more or less in lockdown. So I like having that image there, right? Kind of reminds me that I am home, but I'm home with all you guys also. But at this point, I'd like to turn over to Luca and Nicola. So Luca, I believe you're up first.
Yes, I'm first. So let me start sharing my screen. Hopefully it will work. And here we have the presentation.
There we go.
Do you see my screen? Okay. So today we will talk a little bit about event-driven application development with Camel K, with particular focus on serverless. And so before talking about how Camel K fits into the serverless space, we will have a short presentation about what Camel K and Camel are. We will also have a demo, and we will talk a little bit about what to expect next. So before going ahead, let's have a short presentation about ourselves. My name is Luca, and I'm an architect at Red Hat, and I'm here with my colleague Nicola Ferraro, who is a principal software engineer. We do both work on Camel and Camel K, of course, and with particular focus on Knative, and of course we work on Red Hat integration products. So let's start, and let me introduce Apache Camel. So I think every developer has gone through this path somehow in the past, or maybe also today. So like when you start creating a new application, you want to use the latest technology for the moment. So you want to go at this moment microservices, and you want to use serverless. And of course, because you work in an awesome team, you think that everything is possible. But that's true until you find out and you put your application in the real world. And in the real world, you need to deal with a variety of process and protocol and services. But even if you think what's happening when you want your application to talk with another application, there's a lot of issues you might face. They might not appear at the beginning, but sooner or later you will find that there might be communication issues, like different ways, synchronous versus asynchronous, different protocol language. And you also need to think about what's going to happen when your application is not available, and what's going to happen when, how to ensure consistency of your data. It's not just about technology. Sometimes you also have issue related to a different philosophy of when your application has been written. Just think about yourself and the application you wrote last year. Probably there were a lot of assumptions that are quite different from today. And also, you may have issues because some applications cannot be changed, so they cannot be adapted to the new world. And so think about all the legacy system you have to deal with. So at that point, you start searching for a tool, for something that can help you to solve the problem you are facing. And so you're looking for something that can connect basically everything, and you don't want to write that kind of code. And also you want something that allow to apply some very well-known integration pattern. So you don't want to rethink about what the solution is already there. You just need to apply it. And you want something that is able to run in basically everywhere, so on or off the cloud. And it should be simple. So you need a simple language to express what you want to achieve. Luckily, this is what Apache Camel is. So Assuming that you wrote your application with your fancy new technology, in this case, you want to use Knative, you want to write a serverless application which deal with receiving and producing events. So you put the application in your environment, and you need to wire, for example, another application which is based on Pulsar to your application, and also you want to wire another application which is based on Kafka to your application. But those applications are not natively speaking any Knative jargon. So that's where you can use Apache Camel. So for example, you can use something like that, a route like that. If you look at the code, you can see that even if you don't know what exactly this DSL does, you clearly know the intent. So taking something from Pulsar, from a specific topic, and push to and generate an event on Knative, plus doing some transformation. The same thing can be done on the other side. So taking something from Knative, do some enrichment, and then push the data to a Kafka topic. And in between, you have your application, so where you are free to do whatever you want. So that was about Apache Camel. Now let me introduce a little bit about Camel K. So Camel K, the definition of Camel K is a lightweight integration platform born on Kubernetes with serverless superpower. There's a lot of buzzword here, but it's really the best definition of Camel K. And this is really important to notice that Camel K is a platform. It's not a framework like Camel, but is something that lets you run integration directly on OpenShift and Kubernetes. It's a young project, and it reached the 1.0 version literally 1 month ago. But for the developer, what does it mean? How the developer can use Camel K? So, as I said, the goal of the Camel K is to make let you literally run integration on OpenShift. And that means that you don't need to think about how to deploy your integration. You don't need to think about how to create an application and all that kind of thing. But you literally write your definition, your integration in a file using your preferred languages. Here we are using Java, but you can use Groovy, Kotlin, JavaScript, or some markup language like XML and YAML. And once you have your code, you literally run it. And for example, by using the Camel K CLI, and the command is literally camel run, and then the name of your file, in this case, integration.java. What's going to happen is that in a few moments, your integration is going to be running on OpenShift or Kubernetes. And if the cluster is configured to have Knative, there's a chance that your application is going to run as a serverless application. So in terms of architecture, the heavy work is done by the Camel K operator, which need to install in your cluster. And the operator is in charge of doing a little bit of all the magic. So it's able to understand your integration code and is able to create everything that is needed in order to run your application, including generating all the Kubernetes resources that you might require. But because we want to tailor the Camel K for a true and good cloud-native development experience, we also support live coding. So if you can configure the Camel K CLI to watch for changes to your local code and react to anything. So when you save your file, it's going to push your data to the cluster, and the Camel K operator is going to recreate and redeploy your application. This magic happened because as we said before, we made Kubernetes able to understand your integration code. And if you look at the Camel DSL, it provides a lot of information that can be used by an operator to understand what you want to achieve. The first and very simple thing is just grabbing the list of components you want to use, and so understand what are the artifacts and the dependencies that your application require. And but it can also detect that, for example, in this case, you want to expose an HTTP service, so it's going to create an ingress or route and a service if it is needed. And if Knative is available, it can translate and transform your application in a serverless application, because it understands that your application do not need a persistent connection, so your application can be scaled down to 0. Yeah, that's a little bit everything I have. I try to be as fast as possible to give Nicola most of time and to talk about the most interesting part, which is the relation with Camel and Knative. So I let Nicola to go ahead.
Thank you, Luca. So let me start sharing my screen. I hope you can see it. Okay, let's talk about this relationship between Camel K and Knative. Of course, this is a love story between Knative and Camel K. They are both quite young projects. We started Camel K in the summer of 2 years ago. At the same time, the Knative project was born. Camel K can also run without Knative. If you have an EU Kubernetes cluster and you want to run some integrations, you can do it for sure. But you have the best from Camel K when it runs on top of Knative. This is not the official logo of Camel K, but somebody put the camel icon beside the Knative icon, so it became the non-official logo of Camel K, because they work really well together. So just to be on the same page, I will give you some brief introduction about Knative. So Knative is series of building blocks that you can install on Kubernetes to allow serverless workloads. So basically, Knative is divided into main pieces. One is called Knative Serving, that is about autoscaling. The other one is called Knative Eventing, that is about event-driven applications that are the topic of this talk also. So when we talk about Knative Serving, the most important concept that you have to know is that there is this object that is called Knative Service that you can use to run your own container. Also multiple containers since yesterday, because yesterday Knative OS 16 has been released, and that supports also multiple containers. Yeah, basically you can run your application, and if there is no one requiring your application, there is no pod created for you. So as soon as a request arrives, a pod is created, and if there are no requests for a certain amount of time, the pod is destroyed. So you save a lot of resources. So it scales also down to 0. And scales out when the number of requests are multiple. So if you have a huge load, you can configure Knative to create multiple pods. You configure the limits and how it scales. So how Knative Serving changes when using Camel K, and how Camel K changes when using Knative Serving, nothing changes. So basically, when in Camel K you want to define, for example, an API, no matter if you are going to run it on Knative or on plain Kubernetes, you do this with the Camel DSL. You define an endpoint, and you define a post method on that endpoint, and then whatever is sent to this endpoint, it's forwarded first to this system 1, and system 1 can be one of the 300 components that are available in Camel, and then the response from system 1 is forwarded to system 2. This is the meaning of this Camel DSL, even if you don't know the basics of it. You can understand literally by reading the code. So if you deploy this on a vanilla Kubernetes cluster, it becomes a deployment. If you deploy this on a cluster with Knative installed, it becomes a Knative Serving service. So it scales down to 0 and scales up with the load. But in Camel, everything is code-driven. So you just do the things by writing the Camel DSL that is really powerful. Okay. Let's talk a bit about Knative Eventing. When we switch to Knative Eventing, the most important building block that Knative provides is called the broker. So the broker is an abstraction, is a Kubernetes custom resource, of course, and it is an abstraction for a publish subscribe resource where you can publish, for example, events, and other services can subscribe to the broker using this object called the trigger to receive some kind of events. In Knative, there is a CLI that is called KN that you can download and use and interact with all the custom resources that are defined by Knative, like the trigger, the service, the broker, and the source. Talking about the source is a fundamental part of Knative, is a high-level object. The role of a source is any object that is capable of pushing events inside the broker so that services can subscribe to. You can create several different kind of sources in Knative. Actually, Knative, there are not a lot of sources, but we are going to see that if you use Camel K, you can create really a lot of sources for Knatives, because Camel K leverage Apache Camel under the hood, and it can use a lot of components that are available in Apache Camel. So you can, for example, with few lines of code, you can push data from Twitter directly to the broker, or from Salesforce, or from whatever you want, even from your enterprise application using some custom protocol, because the number of components that are available in Camel is really high. So Camel K is good for creating event sources that push events into the broker. Camel K is also good for creating sync. So pass me this term. The sync term in Knative means a slightly different thing. But I mean sync as a contrary, as the opposite of the source. So you want Camel K, you can do something like listening to some events, then transforming the events into some email that is forwarded to an external service. So we have the INOT component, the SNTP component, the Gmail component, and whatever you need. And it works also with external service with custom protocol, like an external log service. But when you write event-driven application, you are not only limited to use Camel K all the way in all the pieces. So you can use also your own technology. You can use the best technology for the task that you have to do. And also only use Camel K whenever it's needed to do some integration, for example, with external system, or some transformation of the data, because Camel and Apache Camel and Camel K are best doing this kind of tasks. Okay, let's talk a bit more about the event sources now. So Luca told you that there is a main way to use Camel K, and it is writing a Java file, for example, a Groovy file or YAML. And using the Camel CLI, you transform this into a custom resource that then the operator transforms into some running pod. So this is the main way to use Camel K, but there is also a different way. For example, in Knative, there is this concept of source that is a high-level concept in Knative. And we have created these Camel sources that belong to Knative, so they are released together with Knative, and we maintain them. A Knative source, a Knative Camel source, wraps a custom resource, an integration custom resource. I'm telling this to you because I'm going to use a Knative source in the demo shortly. But the difference is that the Camel source can be also interpreted, can be also used with the KN tool when it is compatible also with OpenShift console, with every tool that is based on top of Knative. And under the hood, the Camel source is converted into an integration. Okay, time for the demo. So we are going to do this. I hope it works. We are going to create a trading system. So basically, we want to leverage a machine learning algorithm to tell us if it's time to buy an asset in the stock or to sell an asset. And we want also to receive the notification when it's time to buy or sell in our smartphone using a Telegram chat. So this is what we're going to build. And we are not going to use real stock data, but we are going to use real Bitcoin data. So we are going to fetch the current value of the Bitcoin compared to US dollars. It should be something crazy like $9,000 for a single Bitcoin at the moment. And we're going to do it with the Camel source, Knative Camel source. So we push this data inside this event mesh that is the Knative broker in essence. And we are going to call this API from this Quarkus machine learning algorithm. This API was built by another team, so it's not compatible with the events that are produced by the source. So we're going to create a converter here, a bridge that will call this API and publish some prediction if available. Then we will have a sync here that will publish this prediction to our smartphone. So the three pieces that we are going to create with Camel K are these three. Okay, let's start. Okay, everything we run on OpenShift. This is a cloud instance of OpenShift that we use for testing, and I've already deployed here OpenShift Serverless, that is Knative, basically, serving and eventing. I have deployed the Knative Apache Camel operator. This can be installed from Operator Hub here. and the Camel K operator. These two are global instances. The Camel K operator has been deployed locally, but you can also install it globally on your cluster. This is another view. This is the developer view of what's inside this namespace called Camel Connected. You see the Camel K operator. I have created already the Knative broker. In the latest version of Knative, the broker is multi-tenant, meaning that if you create the broker here in the namespace, in previous version, 2 pods were created in your namespace to support the broker, but in the latest version of Knative, this should not happen, but it was released yesterday. What you see here is a serving service that represents the Quarkus machine learning algorithm that the singular team has built for me and I want to leverage. So let's do all the workflow. We are going to use here VS Code. So this is the scenario. We will start from this Telegram sync. So we want to take predictions that are published by someone on the event mesh and then transform that into a Telegram chat, a message that is sent to our smartphone, okay? And in particular, I want to send them to this chat here, okay? To do it, what you do in Camel K, using Camel, is to init, for example, a file, .java. This creates a file that you can later edit, but I've already done so. I'm not going to do live coding now because we don't have a lot of time. But I can show you what I have already written here. So in this integration, we start from this Camel URI, so Knative event prediction.quarkus. This is the event type that we want to listen. So by calling this to Camel K, we will receive every event that has this type, prediction.quarkus. What we do is to transform it from JSON to something that we can manipulate. Then we form a string. The predictor suggests to buy or sell at this price. We log this into the pod console, and we send it to using the Telegram Camel component to our chat. The Telegram component I show you is one of the 300 and more components that are available here in Apache Camel. Everything is well documented in the Apache Camel website. And also you have here, if you install the tooling for Camel K, you also have here some auto-completion, so the properties that you can write here. Even if this is a string, you have the auto-completion for the properties and also the description of what they mean. So here I'm sending it to this chat that is set in a telegram.properties file. You have to provide the number of the chat. It can be a channel in Telegram, and also provide the authorization token, of course, to talk on behalf of the bot we are using. Okay, let's go back to this. The last line here means, okay, in Knative, whenever you receive an event from the broker, you have the option to reply with another event that is injected again inside the broker. But here, by setting this body of the message to empty, we are telling just Knative that you want just to consume the event without replying. Okay, how do you run this integration? Camel run Telegram sync.java, and it's run. Well, Camel K tells me that it has loaded automatically this property file Telegram.properties because it's declared here in this mode line. Okay, if we go here to the console, the topology, we see this Telegram sync that has started. You can go back here to look at what it's doing, but let's see why. If you look at here, it has generated a Knative serving service. So let's look at what happened under the hood. If you get, for example, K in my laptop is kubectl, so K get IP. IP stands for integration. You see that we have created a Telegram sync integration that is currently running. We can execute get KSTC. So we have created this Telegram sync Knative service automatically from this code. The Quarkus ML is another service that was already running on the namespace. And there is also trigger here. So this is the default Telegram trigger. If we look closely at what's inside this trigger, you will see that this trigger tells Knative that whatever is set to the default broker with attribute type equals to prediction.quarkus. So every event with type prediction.quarkus should be sent to the service called the Telegram sync. We have not created any of this YAML because the operator has done everything for you. So the only thing that a developer needs to say to Camel K is we want to start from a Knative event prediction.quarkus, and Camel K creates the trigger, the service, and everything that you need to run this integration. Okay, let's go back to the picture. We have created only this, but if you go to the cluster, this has scaled down to 0 because it is not receiving any event. And the Quarkus machine learning algorithm is also auto-scaled to 0, as you see. So let's feed this with some data. Let's start from the beginning. Let's create the source. Okay. As I told you before, there is a different way to create specifically sources written with Apache Camel K, and it is this. So using Camel sources belonging to Knative Dev. So this is an example of Camel source. That basically contains the Camel DSL, the Camel code written in YAML. This is well tested because the YAML DSL belongs from the XML DSL that is already available in Camel since a lot of years. So this is what it means. We start with the timer component that is out of the box available in Camel, and every 10 seconds, we query the finance market for Bitcoins, in this case using the exchange component that is one of the 300 components in Apache Camel, and we want the pair Bitcoin versus US dollars. We take the JSON as it is, marshal it, we log something in the console, and then we set the content type and send it to the broker, to the default broker with this type, market Bitcoin USDT, so that services can subscribe to it. So to create this, you use kubectl because it's a standard Kubernetes resource called market source.yaml. But when you create it, under the hood, you see here in this window that the Telegram sync is an integration that is running, but also an integration called market source that is wrapped by this Camel source is running. We can follow the logs from here of this. And you see that this is generating some JSON data, the currency pair, Bitcoin, USDT. The most important information here is the value of the last value of the Bitcoin versus US dollar that we want to leverage. If you look at the console, the source is running. It has this beautiful icon because it's a standard Knative source. Okay. The only thing that we need to create now is this prediction bridge that bridges this, whatever is generated by this source, with the machine learning algorithm, and then forward the direction to Telegram. The machine learning algorithm is the basic one. It has a simple interface. Sorry if it's not, it doesn't seem correct, but it's only the ID that is not accepted. So it accepts under the samples endpoint a double value, and then may return an action to do, to buy or to sell some Bitcoin. So we are to feed this machine learning algorithm by sending only the current value of the Bitcoin versus US dollars. So this is what we are going to do now in this integration called prediction bridge, that is Apache Camel K integration. So we listen to each event update from the source, so the current value of the Bitcoin versus US dollar, that is the JSON, we transform it, taking the last value, so only the double value, and then at the end we call this API, and asynchronously, the wiretap, taking from the wire the response from that service, we evaluate the response, and if it's not empty, we send an event of type prediction.quarkus with the action that we have predicted. So this is what it does. It seems complicated, but it's really not complicated. Run this. I type camel run prediction bridge.java, and okay, it's created. We can follow here the logs of this integration. It's starting already. It's running on a remote platform. It's not running locally in my machine. And you see it has started. Oh, it has received something. So also the Quarkus machine learning service is starting because this integration is calling the machine learning algorithm to know if we have to do something. Okay, so it's sending some data, but there is no prediction at the moment generated by the Quarkus machine learning. So this Telegram, okay, now we have a prediction. You see here in the log. So the Telegram event starts, and if we go to the Telegram chat, we're going to receive the prediction to buy. Yes, oh, you have to buy Bitcoins because the price is now increasing. So this is also a suggestion for you if you want to take it. Okay, so this completes the picture, and we can go back to the presentation to talk about the future. You have also a recording here if you want to look at it offline. There are also other things that I've not said in this presentation because we have not a lot of time. Let's talk about the future. What I've not shown to you is that, okay, Apache Camel is based on Java, and whenever you run some integration written with Apache Camel, it runs on an OpenJDK pod with Quarkus. Quarkus is currently optional, but it will be the default shortly. The problem with this approach is that a JVM uses a lot of memory compared to a native executable, for example, compared to Go. So what we are going to do next is to not create a pod with OpenJDK and the Quarkus application, but compile natively your integration so it becomes something really tiny. And what you will get from this is that instead of using, for example, 200 megabytes for an integration, you will use 28 megabytes, like in this example. And also the startup time. You've noticed that from the time where the Telegram integration started to when we received actually the data in our chat, it took 5 seconds almost. But with the Quarkus native compiler executable, you will get it in less than 1 second. So there is this new project that is downstream of GraalVM for running Quarkus for compiling Quarkus natively, and it's based on OpenJDK. And we're going to leverage it. Another thing that is really cool, and we are going to work on, and we are actually currently working on this, it's the concept of camelets. So a lot of people, also many of you probably, are not Camel native users, so they don't know about Apache Camel and the DSL. So with this concept of camelets, basically, we are going to provide some specific Camel routes for you, basically. So we'll create some kind of connector that people can just pick and use without thinking about the Camel DSL. So for example, you pick a Twitter camelet, and then also there will be some user interface, a graphic web user interface where you can configure, for example, the query parameter, what you want to retrieve. For example, I want to retrieve all tweets that talk about Quarkus and in the internet. I configure the token for Twitter, and then I choose the destination. I want to send this to this Knative endpoint or this broker, and then everything else is done automatically by the operator. You just need to configure the stuff. And you don't write any line of Camel code. Camelets can work also to build not only sources, but also sinks, to push data from the Knative event mesh up to outside. And also Camel developer can use them as high-level building blocks when they write their routes. So they are really an interesting concept. And also Yak. So this is a framework that we like a lot, and it is about testing. So how do you test Camel K integrations? How do you test services? This is a nice idea of using BDD style testing, so behavior-driven development style testing. In this context, you write a feature file that seems a natural language. So here we are going to test this feature that the API works. The URL is this, and we want to test this scenario that when sending a get, an HTTP get on /endpoint, and then we want to receive an HTTP to 100OK. So this seems natural language. It's actually a runnable test that it can run with Yaks, and it runs inside Kubernetes, so where your integration are running, where you have Kinetic, and where you have all the things that you want to test. This is part of Citrus framework, and we really like it a lot. There are other important future developments that we are working on. Webhooks, so most sources in Apache Camel cannot scale down to 0, while the services can. So we want to improve the number of sources that cannot get scaled down to 0, including using Kida that is also brings also auto-scaling for not HTTP workloads. differently from Knative. Okay, if you want to learn more about Apache Camel, there is a recent DevNation talk by Andrea Cosentino and Klaus Ibsen from some weeks ago. And there is also another talk about Camel K from last year from me and Luca Burgazzoli. So you have the resources to learn more. And yes, okay, go to GitHub to see Apache Camel, use it, contribute. We love any kind of contribution, from documentation to bugs. So you don't need to write code to contribute to this project. Just use it. Follow us on Twitter if you want to have some news. I'm Ni_Ferraro, and L. Burgazzoli is my colleague that will reply to your question shortly.
Okay, well, we are actually out of time, but there are some key questions I want to mention we've tried to get to. One is, and you answered it towards the end, not every Camel component is appropriate for, let's say, multi-pod. Like 15 of those pods would not make a lot of sense. Maybe like the file source as a good example. And the other thing is they're not appropriate for scale to zero. So is there any way we can have a chart that basically goes to those components and says, yep, this one could be multi-pod, this one could be scale to zero. In other words, it's really optimized for this kind of Camel K dynamic scale from 0 pods to 20 pods and back down to 0 pods. What do you guys think about that?
Yeah, of course. Yeah. If you think to file, or if you think to FTP, for example, and you need to do some polling. Also for getting the data from the Bitcoin, they don't define any webhook that we can use. So the only way to integrate with them is through polling. So this means that we need to have some poll that is always running. In Camel, among all the components, we know which ones can scale down to 0 and which ones cannot. Because we use this information inside the operator, because when the operator reads what we are going to run, it knows where you are starting your routes from. So if you are only using components that can scale down to 0, then your integration is transformed to a Knative service. If not, it's transformed into a deployment. So we have this information. We need to make it public, for example, on the Camel website. This is a good idea, so that people know which components can scale down to 0, of course. For Knative, components that are based on HTTP can scale down to 0, but we want to improve this in the future to make also, to leverage also KIDA, to have also other components that to scale down to 0 in the future.
Go ahead and stop sharing. I don't know what to say. Changes. So one other question, and Tino and G. So Tino has lots of questions, and he's specifically interested in what about event correlation. So event correlation IDs would be critical, and then that's related to what other attributes can we match on? So we know we can match on the cloud event type, but what other attributes can we match on? Cloud event source, cloud event type, cloud event, even like date time correlations. Right? What can we do from a correlation standpoint?
Yeah, okay. When you receive data from Knative, you can specify on the trigger multiple criteria to filter on. So you can specify the event type and also other criteria. There is not a fixed schema in the event that you publish on Knative, so you can define your own attributes. In Camel K, also you are able to filter them. I've not shown it in the demo. But the Camel is based on URI. So if you continue and look at the properties that are available on that native URI, you can also add some additional filters. So you can filter additionally to other properties that you can determine on the event. The only limitation is that you have to filter for equality. So this is a limitation in Knative. So you can receive events that have this property equal to this.
And it's only what I call message header level properties, right? You're not looking inside the body of a message.
You cannot do it. You cannot do it by using Knative primitives, but you can do it later in the Camel route, of course. So you receive all the event type of a certain type, and then you filter out with Camel after you inspect the body. So you can do it inside. This means that if an event that you are not interested in arrives to your pod, it scales up to receive this event, but then the Camel route will skip it. So this is the only thing. But there is not some primitives that we can push back to Knative to avoid our pod to start. But that, of course, can be done.
So thank you for that, because I think those are probably key questions. When Tio you can always email me or email these guys. We'll maybe take some of the questions offline, because I think you're asking some very advanced topics. But I do appreciate the fact that you're very interested in these concepts, because everybody's going to be interested in event correlation IDs, how to deal with temporal data, date times, things like that. Okay. I would never put such stuff in the body. Body-based routing is proven to be a route to hell. So, by the way, Nick's basically saying don't do content-based routing. And and we know Nick, right? Nick from Luxembourg. If you know Nick, he's also going to be putting this in production soon. So that's the good news. He's going to be using Camel K in production very soon. Ooh. And thank you guys for your time today, though. We are out of time. We got to set things up for the next presenter. We're going to be talking about kubelets here in a few minutes. But Luca, Nicola, awesome stuff. I did put your Twitter handles in the chat, so people have that. The slides will go up on the main URL that you guys are currently looking at shortly. And if you have further questions or thoughts or input or ideas, feel free to email me. You all have my email address, because the email comes out from me, because I get 700 plus bounce backs because people are on vacation today, right? And I got them all this morning. Maybe it was 900 bounce backs for people on vacation today. Okay? So I thank you all for your time. And if you guys have further questions, just send me an email. Awesome stuff, guys.
Thank you.
Thank you.
All right. We're out of here for this stream. We'll see you in the next one.